Okay, last shape. We're almost done. And I'm giving you all the answers for the whole activity. This should be an easy 100. Easy 100, because I'm giving you all the answers. Anyways, I digress. So we're on to trapezoid. It's the last shape in the activity. And it's it's a different type of shape. So for the definition of a trapezoid, all you need to be a trapezoid is you've got to have 4 sides, which we have, count them, 1, 2, 3, 4. And one pair has to be parallel. If you notice, we've got TR and AP parallel. And yes, some have figured out that the way I named them, they spelled trap. It's a trap. Anyways, that's our definition. One set of opposite sides parallel. Now, just a plain Jane regular old-fashioned trapezoid only has one other property. And they tell us to measure the angles to find the property. Okay, well, I'm going to measure them. Let's see, this one's 123 degrees. This one's 57 degrees. This is going to be 71 degrees. And this one's going to be 109. Now, what do we notice about the angles here? What do T and P add to? 180. What about R and A? 180. That's because consecutive angles are supplementary. That's the only real other property that a regular plain Jane trapezoid has. So let's take that, and we're going to kind of jump around on this page. Let's go down here to find the measures of this regular trapezoid. A, B, C, D. So what do we say about consecutive angles? So what did I say about B and C? And then A and D. What do they have to add to together? 180. Together, they better give me 180. So let's get B first, since I'm already writing in red. We could do 180 minus 92. That gets us 88 degrees. So there's that one. And then D, 180 minus 120. That gets me 60. There's that one. Okay, fill the blanks in. Measure of angle D. Well, we said that was 60 degrees. Measure of angle C. We said that was 88 degrees. That's all you can do with a regular trapezoid. Not too thrilling, is it? But we have isosceles trapezoids. So let's look at those and see if those can be more fun. Now, we know they have to have the same properties. So ZO and ID have to be parallel. What makes a trapezoid isosceles is that the legs are congruent to each other. So ZD and OI are congruent. That's what makes a normal trapezoid turn into an isosceles trapezoid. The legs are congruent. It's also it has to have the same property we discovered above. That one set of opposite sides are parallel. It's got to have that same property. Okay, number 3, measure the angles of the isosceles trapezoid to discover another property. So I'm going to give you those angle measures. That way you have them. So angle Z right here is 75 degrees. Angle O right here is 75 degrees. D is 105 degrees. I is 105 degrees. So what do we notice about the angles? Yeah, consecutive angles are supplementary. 75 plus 105, yep, that's the same. But if I look on each base, so if I look at DI, what do I notice about both of those angles? They're the same. What about if I look at ZO? They're the same. That's because on an isosceles trapezoid, base angles are congruent. Okay, then they ask us to draw in the diagonals and measure them to find yet another property. So let me draw in my diagonals here. So there's my diagonals. Now, if I measure these, I would easily find that the diagonals are congruent. Okay, so number 5, how many lines of symmetry does an isosceles trapezoid have? Well, if I try to fold that in half, how many ways could I fold it in half? Just one. Put the Z towards the O, the D towards the I, and I can perfectly fold it in half. So it has one line of symmetry. So those are our properties for an isosceles trapezoid. Let's use them to solve this problem down here. So we're going to label every possible thing that we can. So let's see here. They tell us that AE is 8 centimeters. So I'm going to write that in. AE is 8 centimeters. BD, so the whole segment right here, BD, is 20 centimeters. Okay. Let's see what we can use to find everything. Well, sidewise, this leg, remember legs have to be congruent. So this one's also got to be 14 centimeters. Diagonals are congruent, so this has to be 8 centimeters. If B to E is 8 centimeters, how much does that leave me to get from E to D? Well, 20 minus 8 gives you 12. So this is going to be 12 centimeters, which means this one is 12 centimeters. So I've labeled all my segments. Now let's turn our attention to angles. So this one is 30. That means 3 down here has to be 30 degrees. Well, let's focus for a second just on this triangle right here. I got 30 and 30. How many degrees does that leave me with for angle 6? 30 plus 30 is 60. 180 minus 60, 120. So that means angle 6 has to be 120 degrees. If 6 is 120, that means 7 has to be, since they're on the line, 7's got to be 60 degrees. Totally writing down the wrong color for angles. Well, now let's focus on the triangle just to the left of the one in pink. We got a 72, a 60, and a one I don't know. So let's figure out the one we don't know. 72 plus 60 is 132. Subtract 132 from 180. 48. So angle 4 is 48 degrees, which means angle 5 is 48 degrees. Again, I know that's 60. I know that's going to be 72. This one has to be 120. Because they're vertical angles. Well, if this one's 120, in order to keep these the same, since these are both 8, then these have to be 30 degrees as well. Okay. It looks like we've got everything, so let's try to fill the blanks in and see if we can call it a day. So the measure of angle 1, we said that was 30 degrees. Measure of angle 2, we said that was 30 degrees. Angle 3, 30 degrees. Angle 4, we said was 48 degrees. Angle 5, 48 degrees. Angle 6, 120 degrees. Okay, let's see. Angle 7, 60 degrees. Did we find BC? We did. 14 centimeters. What about BE? Yep. 8 centimeters. Remember, E is this point in the middle right here. EC. EC, we said it was 12. And then AC. So A to C, diagonals are congruent, so this one's also 20 centimeters. Okay, looks like we're done. So this was the last of our parallelogram activity. Again, make sure you filled out the whole assignment, submit it, do that all correctly, get 100. So I know it took us a while, but we've learned some important properties that we'll touch on again later in the week. So until next time, I'll talk to y'all later. Signing off.